Here is question number 16. This is from related rates. We have an equation given. That equation is 4x squared plus 9y squared is equal to 25. This gives a relationship between x and y. Okay. Then we have given that x and y both are functions of t. Now x and y both are dependent on t here. T is the independent variable. So we are going to differentiate the given equation with respect to time here on both sides. Please remember we are differentiating both sides. Okay. Remember in this question x and y both are functions of t. Okay. So when you differentiate 4x squared, the answer would be 8x times dx by dt, because x also is not an independent variable here. X is a function of t, plus when you differentiate 9y squared, it will be 18y times dy by dt is equal to derivative of 25 is 0. Now you guys notice we are given with some facts. Dx by dt is 3, this one. X is negative 2, this one. Y is 1 here. So we're going to put all the values here. 8, x is given as negative 2, dx by dt is given as 3, plus 18, y is given as 1, dy by dt is not given, equal to 0. And if you notice, this is what we need to actually find. We need to find this. So all we have left here is simplify this equation. 8 times 2, 16 times 3 is 48 plus 18 dy by dt is equal to 0. I'm going to add 48 both sides. So 18 dy by dt should be equal to 48. So dividing both sides by 18 would be 48 by 18. And they both have a factor of 6 in common, 8 by 3. So the question was to find this. Dy by dt is 8 by 3. That's your answer. Here is question 17. It says the particle moves on a hyperbola. The relationship is given as xy equal to 12. As it crosses the point 3, 4. So x is given as 3 and y is given as 4. Its y coordinate is decreasing. Decreasing means y coordinate is change in the y coordinate with respect to time is given as 4, but it's negative. Why is it negative? Because of the decreasing. Let's see the question. What is the rate of change of x? So what basically is asked is to find rate of change of x. X is changing with respect to time in the question. Okay, at this moment. Now we have this equation given. The first step would be differentiate equation with respect to time on both sides. Now remember, these are related rates questions. Here x and y both are dependent variables on a third variable, which is t. So when I differentiate this, this is product of two functions. X's derivative is 1 times y as is, plus one more time. X's derivative is dx by dt here, not 1, because we are differentiating with respect to time, times y, plus x as is dy by dt, because y is also function of t, is equal to 12 is constant. 12's derivative is for sure 0. Now we have been given some things. Dx by dt is not given, so I don't know that. I'm going to just write that. Y is given as 4, so I'm going to write 4 here. Plus x is given as 3. Time dy by dt is given as negative 4, equal to 0. So let's write this down one more time. Dx by dt times 4, negative, you can write this 4 in the front if it's confusing you, is equal to 0. adding 12 on both sides. 4 dx by dt is equal to 12. Dividing by 4 on both sides, dx by dt would be 12 by 4. The answer is 3. So dx by dt is coming as positive. That means x coordinate is increasing at the rate of x coordinate is increasing at the rate of 3 centimeter per second. That is the interpretation of it. Let's work on question number 18. The position of the particle moving on a straight line is given by s. S is basically here function of time. Distance is in meters, time is in seconds. The first question is to find general expression of velocity. So let's work on that. Velocity, if you remember, we talked about is the derivative of the displacement. So basically we need to differentiate this function. Derivative of t cube is 3t square minus derivative of 9t square is 18t plus 24. That's the velocity function. We are done. Velocity at 2. So that is asking v at 2. All you need to do is put 2 here in place of t. 3 times 4, 12 minus 36 plus 24. That is actually coming 0, I think. Okay. Part B. Any time when particle is stationary. What does stationary mean? Stationary means it's not moving. Not moving means velocity at that time is 0. So we need to find time when velocity is 0. So velocity is 0 if this thing is 0. 3t square minus 18t plus 24 is equal to 0. This is a quadratic equation. We can factor 3 out. That will make it 3t square 6t plus 8 equal to 0. 3. This is quadratic. It can be factored easily into 2 factors. It should be t minus 4. I think t minus 2. Because sum of these two should be 6, negative 6, and product should be 8. So t is at 4 and 2 seconds. Particle is stationary. Okay, let's talk about part C. What is acceleration at t? Acceleration is the derivative of velocity. Velocity is this. So we just need to differentiate it one more time. 3t square's derivative is 6t minus 18t's derivative is 18 plus 24's derivative is 0. We do not need to write that. What is it at t2? So that's asking you acceleration at 2. So you just need to plug 2 here. That means 12 minus 18. That should be negative 6. Here it will be meter per second square. Okay, units of acceleration. That means it's like we are deaccelerating because it's negative. Velocity is decreasing.